Hello again. Today we're going to take a look at collision detection. This is an interesting topic for physics simulations and game design, or really any time we're trying to model real-life motion in our software. If you take a look at this sketch that I prepared, we've got a program that, if we were to run it, draws an ellipse on the screen. We have set the three variables: E diameter for ellipse diameter, EX and EY for the X and Y coordinates of the center point, and we're initializing those in our setup to a diameter of 200 and an X and a Y coordinate of the middle of the screen, halfway between the width and halfway between the height. And if we look at our draw loop, every time through the frame we draw a white background, we set our fill color to white, and then we draw an ellipse at our EX and EY coordinate. And the third and fourth arguments are simply the width and the height, so we use the diameter for the width, and then we also use the diameter for the height. Now our goal is to extend this program so that we can detect a collision between a point and this circular object we've drawn on the screen. Now for a point, we'll use the mouse's location because processing gives us the mouse X and mouse Y coordinates very easily, and that represents a point in 2D space. So before we jump into the code, let's first consider a general algorithm for detecting a collision between a point and a circle. In basic terms, a collision is considered to have occurred if either the point is in line with the outer edge of the circle, or the point is closer to the center point than the circle's outer edge. A key property of a circle is that the distance from the center point to any point along the circle's edge will always be equal to the radius of that circle. The basis of the algorithm relies on being able to determine the distance between the center of the circle and the point. If that distance is equal to or less than the radius of the circle, a collision is said to have occurred. As we jump back into the sketch, one of the first things that we're missing in our program is that radius. We need that value to compare to the distance from our point to see whether or not a collision has occurred. Now you may be thinking to yourself, well, we already have a diameter, so getting a radius is trivial, and you are correct. We simply can create another integer variable, call it radius, and then we can just write an expression where the radius is going to be whatever our diameter has been set to divided by 2. This gives us access to that value that we need to do the detection. The other tricky point about the algorithm is determining the distance between our point and the center point of our circle. Now, we could use some trigonometry from high school math with Pythagorean theorem to figure out the distance in x direction, the distance in the y direction, and then figuring out the hypotenuse between the two. That's going to represent the actual distance between the 2 points we're interested in. Luckily though, because that's a pretty procedural process, processing has already implemented this as a function that's available to us. The dist function takes 4 arguments, the first 2 being an x and a y coordinate of one point in space, and the third and fourth being the x and y coordinate of another point in space. The function will calculate the distance between the 2 points and return that value. To build our condition, let's first write it out in pseudocode. As we discussed earlier, if the distance between the point and circle center point, if that is less than the radius of the circle, then we have a collision. Now let's put that into code. If, and we can leverage the distance function, our first 2 arguments are going to be an x and a y pair of one of our 2 points, so we'll use mouse x and mouse y. And our third and fourth arguments are the other x and y pair, and we'll use EX and EY as those are the center point of our circle. So if the distance between the 2 is less than the radius of our circle, then we should have a collision. To keep things quite simple, all we'll do here is change the fill value to some arbitrary color so that if this condition succeeds, before the ellipse is drawn on that frame, the fill color is going to change, so that we basically should have a mouse over effect, that if the mouse point is colliding with that circle in any way, that the color is going to change. So let's test that out. And we can see that if we move our mouse onto the edge of the circle or any of the interior space, that we have that simple collision. So that's point and circle, one of our most basic cases. Stay tuned and we'll try taking a look at mouse and rectangle next.